In this video, we're going to learn the first part of solving systems using elimination. And this part only requires you to either add or subtract the equations. So the elimination method is the best way to solve a system when both equations are in standard form. And remember from our last unit, the standard form is ax plus by is equal to c. So if I take a look at these, we're going to determine whether or not each system of equations is set up for elimination. So if I look at these two guys right here, 7x plus 8y equals -9, that one's in standard form. 10x plus y equals 2, that one's in standard form. So yes, this system is set up to use elimination. Example number 2, I have x equals 2y plus 3 and 4x plus 5y equals 6. If I look at this first equation, that's not set up very well for elimination. This is not in standard form, so the answer is no. And if I think back to the last section where we talked about solving systems by substitution, this one's actually solved for x. So in fact, this one is set up pretty well to use substitution. All right. Example number 3, 2x minus 3y equals -1, and 9x minus 3y equals 7. Both of those are in standard form, so yes, that's set up again pretty well for substitute or for elimination. All right, steps. So here we go. We're going to identify the variables with the same coefficient, i.e. if you have a 3x and a 3x, both of those have the same coefficient of 3, or opposite coefficients, such as 2x and -2x. This guy has a coefficient of 2, and that guy has a coefficient of -2. That's the variable that we're going to work to eliminate. So in this first example, the variable that we're going to eliminate is the x, because I've got a -6x and a +6x, and both of those variables have coefficient, they're opposites, -6 and +6. So we're going to work to eliminate x. All right, so step 2, we're either going to add if they have opposite coefficients or subtract if they have the same coefficients, the equations, in order to eliminate one variable. So in this case, I have opposite coefficients, so I'm going to add them together. Okay, and I like to put that second equation in parentheses just to kind of help me remember what I'm doing. Okay, and it is very important that you line up the x terms, the y terms, and then the constant terms, as well as the equal sign. And we want to work on this vertically, again, with the variables lined up. Otherwise, it's going to get really tricky for you. So -6x plus 6x. So I'm going to add coefficients. -6 plus 6 is equal to 0x. So these two are going to cancel. -3y plus -8y. So I add the coefficients together. -3 plus -8. That gives me -11y is equal to 15 plus 40. 15 plus 40 is 55. Okay, then we can solve for the remaining variable. So I have -11y is equal to 55. In order to solve for y, I would divide both sides by -11, and that gives me y is equal to -5. Okay, then I can substitute the solved variable into one of the original equations, solve for the remaining variable, and write the solution as an ordered pair. So I can pick either one of these equations that I would like. It doesn't matter to me which one you use. So let's go with the first one. I have -6x minus 3y is equal to 15. I'm going to plug this in for y. So -6x minus 3 times -5 equals +15. Simplify, so -6x plus 15 is equal to 15. And come back up here so I have a little bit more room. -6x plus 15 equals 15. I would have to subtract 15 from both sides, and that leaves me with 6x is equal to 0. Divide both sides by 6, and I get x equals 0. So my final answer should always be in the form of an ordered pair. So in this case, it's going to be 0, -5. On the next page, we have a couple more examples. All right, first example, I have negative 7x minus 9y equals negative 75, and then 2x plus 9y equals 60. So the variable that we want to work to eliminate in this case is y, because they have opposite coefficients. I have a negative 9 and a positive 9, so we're going to try to eliminate y. All right, so negative 7x minus 9y equals negative 75. Notice I'm going to line everything up nice and neatly. 2x plus 9y equals 60. Parentheses around the second equation, and I'm going to add them together because the coefficients are opposite. So negative 7x plus 2x, so negative 7 plus 2 is negative 5. Negative 9 plus positive 9, that gives me 0, so that's going to cancel out, is equal to negative 75 plus 60 gives me negative 15. All right, in order to solve that equation, I'm going to need to divide both sides by negative 5, and I'm left with x is equal to 3. All right, plug back in to find y. Doesn't matter which equation you pick. I'm going to use the second one because all the numbers are positive. Makes less chance of getting a signs error. So I have 2x plus 9y is equal to 60. I'm going to plug 3 back in for x. So 2 times 3 plus 9y equals 60. 2 times 3 is 6. So 6 plus 9y equals 60. Subtract 6 from both sides. And I have 9y equals 54. And divide both sides by 9. And I end up with y is equal to 54 divided by 9 is 6. So remember, final answer should always be ordered pairs. So my x is 3 and my y is 6. So my final answer is 3, 6. All right, second example on this page, I have 7x plus 3y equals 12 and 2x plus 3y equals negative 3. I'll pick a different color here just so they don't run together. So the variable that has the same coefficient in this case is the y. So again, we're going to work to eliminate y. All right. So that gives me 7x plus 3y is equal to 12, and 2x plus 3y is equal to negative 3. Parentheses around the second equation, and in this case, I'm going to have to subtract the second equation from the first. So notice these two have the same coefficient, they're not opposites, so I'm going to have to use subtraction. So 7x minus 2x is going to give me 5x. 3y minus 3y is 0y. And 12 minus negative 3 is the same as 12 plus 3, so it's going to give me 15. So I've now successfully eliminated y. Divide both sides by 5. And again, in this example, x is equal to 3. Now that I know what x is, I can go ahead and find y. Doesn't matter which equation you plug into. 7x plus 3y is equal to 12. So 7 times 3 plus 3y equals 12. 7 times 3 gives me 21. Subtract 21 from both sides of that equation. So that's going to give me 3y is equal to negative 9. Divide both sides of that equation by 3. And I'm left with y is equal to negative 3. So final answer is an ordered pair, 3, negative 3. All right, last example for today. If I take a look at this system right here, I notice something. I notice that I can either work to eliminate x or eliminate y. So I can go ahead and choose. Since we've been eliminating x this whole way through, let's work to eliminate y. Since we've been working to eliminate y, let's go ahead and eliminate x. Okay, so I have 5x plus 4y equals negative 8, and 5x plus 4y equals negative 4. If I look at my x's, they have the same coefficient, so I'm going to need to subtract instead of add. 5x minus 5x is 0. 4y minus 4y is also 0. So altogether on this side of the system, I'm going to have 0 as equal to negative 8 minus negative 4. So negative 8 plus 4 gives me negative 4. And something odd happens. All my terms cancel out. Now I'm left with something that's always false. 0 can never equal negative 4. And when that happens, that means there's no solution to this system.